Hello everyone. Our today's A-level chemistry topic is the reaction of halides with concentrated sulfuric acid. Whenever we take, whenever we want to produce halidic acids, then we can treat solid salt of halide with concentrated sulfuric acid into a sealed round bottom flask. Via delivery tube, all gases produced can be collected into beaker. Now, if we take, for example, if we take sulfuric acid and sodium fluoride reaction into this round bottom flask, this product will be formed sodium hydrogen sulfate and hydrofluoric acid will be produced. Similarly, if we take sodium chloride, we will get hydrofluoric acid. If we take sodium bromide, we will take hydrobromic acid. And if we take sodium iodide into the round bottom flask salt and then react with concentrated sulfuric acid, we will get hydroiodic acid, HI. All these produced these are gases. These are gases. And these are collected into the beaker. But as sulfuric acid is acting as an oxidizing agent, but sulfuric acid cannot oxidize hydrofluoric acid and hydrochloric acid further. Hydrofluoric and hydrochloric acid are observed as a white misty fumes produced as a result of the chemical reaction. But when we treat sodium bromide with concentrated sulfuric acid, it produces hydrobromic acid. Now, this hydrobromic acid is more stronger reducing agent than HF and HCl. So, sulfuric acid can further oxidize this HBr, and HBr on reacting with sulfuric acid produce bromine gas, sulfur dioxide gas and water. And bromine gas comes out in the form of red-brown fumes, a very significant colored fumes producing process we will observe. Next, if we use sodium iodide and react with the concentrated sulfuric acid, as a result we will get hydroiodic acid. But this is a strong reducing agent. So, its reaction with further sulfuric acid becomes possible. It reacts in a different ways. For example, if lesser number of moles of HI react with sulfuric acid, it will produce iodine, sulfur dioxide and water. If concentration of hydroiodic acid will be increased, it will react with sulfuric acid producing iodine gas, solid sulfur and water vapors. Even if a further concentration of hydroiodic acid is increased, then it will react with concentrated sulfuric acid producing iodine gas, H2S gas and water vapors. And the iodine produced comes in the form of violet vapors, and violet vapors are clearly indicated where the indicate that iodine is producing here. Now, this is the strongest reducing agent, so its reaction with sulfuric acid takes place in different steps. But just like the production of HF and HCl, the production of both of these HBr and HI. This is not a good method to prepare HBr or HI as a result of the reaction of their respective salts with the concentrated sulfuric acid because their reducing power increases which further reacts with sulfuric acid, and as a result mixture of different gases along with, for example, HBr, HI, sulfur dioxide, bromine, then sulfur dioxide, and then H2S, hydrogen sulfide. All these are produced side by side. That's why this method is not considered to be a good method for the preparation of HBr and HI, because these are strong reducing agent and these reacts with the concentrated sulfuric acid further as an oxidizing agent, and the further reaction takes place producing variety type of the different byproducts. Those will contaminate all those gases we will produce during this reaction. Now all these reactions indicate that how different way these halide behave. In the first reaction, fluoride, second chloride, bromide, and iodide ions are present. Now the strongest reducing agent is iodide and weakest one is the fluoride. That's why the reaction of both iodide and bromide with the concentrated sulfuric acid takes place and further proceed in variety of ways, producing mixtures of different gases contaminating the final products. Next is the disproportionation reaction. Disproportionation reaction. This is the type of reaction. Disproportionation reaction. Disproportionation reactions are those reactions in which the same element oxidized and reduced. Those are called as disproportionation reaction. For example, chlorine reacts with sodium hydroxide. Fluorine reacts with sodium hydroxide and producing NaCl, NaClO, and water. This is the reaction of chlorine with sodium hydroxide solution in cold state at a lower temperature. Whenever chlorine gas is possible, because the chlorine is acidic gas. This is alkali reaction, acid base takes place, salt are produced. But here the same element chlorine, which has oxidation state 0 here, but its oxidation state comes here -1 and here comes +1. It means that the same element is reduced here, but the same element is oxidized here. Such type of the reaction in which the same element is oxidized and reduced, these are called as disproportionation reactions. But in case of hot condition, 3 molecules of chlorine react with 6 molecules of NaOH, producing in hot condition, producing NaCl, 5 NaCl plus NaClO3, and then producing plus 3H2O. Again, at a higher temperature, the oxidation state change. Here the oxidation state of chlorine is 0. In NaCl, the oxidation state of chlorine is -1. It means that it is reduced. But in case of NaClO3, it is +1. This is -6, and chlorine will have oxidation state +5. It means that from 0 to +5 it is oxidized. The same element is oxidized in case of hot condition if we pass chlorine gas through a hot sodium hydroxide solution. Here the sodium chlorate 5 is formed, but here the sodium chlorate 1 is formed. Sodium chlorate 1 is formed. Now this sodium chlorate 1, NaClO, with positive ion oxidation state, this is used as a bleaching agent, and actually the ion chlorate 1, ClO1, is acting as a bleaching agent which removes the stains and other greasing particles. Now, halogens, just like chlorine, whenever it will be added into water, it will produce two acids, hydrochloric acid and then HClO. Chloric 1 acid. Here -2, +1 and +1. Oxidation state is there. Now this HClO again will decompose quite easily. HClO producing HCl and plus atomic oxygen. Now this atomic oxygen will react with the stains, bacteria, to destroy them, to remove the color. So in this manner all these are used in sterilization process and as a bleaching agents. Now further uses of halogens, we know that in case of PVC formation, PVC, polyvinyl chloride. For example, if we have acetylene and we react with HCl, we will get CH2 double bond CHCl. This is called as a vinyl chloride. Now this vinyl chloride is polymerized CH2 CHCl. This will polymerize producing such type of polymer. This is called as polyvinyl chloride, so on. Now this is the small representation of PVC polymer, which is also obtained from the halogen compounds. Now halogen compounds are also used as general anesthetics, and these are also, we have already learned that a very renowned compound, polytetrafluoroethene, is made from tetrafluoroethene. If this is polymerized, this will produce polytetrafluoroethene, which is abbreviated as PTFE. Also a valuable compound which is produced as the polymerization of the tetrafluoroethene into poly. Such type of the compounds are used as a non-stick pans, and also a wide range of application is there in the chemical industry. So from the uses of halogens, it is observed that these all elements are antiseptic in nature. For example, so many different remedial salts of iodine are just like pyodine and iodex. Then iodine is also used in the form of salts for the treatment of a disease called goiter, and silver salts also silver salts of these halides are also used in photography. So many uses are there. I have explained all the concepts regarding reactions of disproportionation and also the reaction of halide with the concentrated sulfuric acid. Please comment, like, share and subscribe my YouTube channel to get the next upcoming valuable video lecture.